In this video, continuing 5.2, I want to look at using transformations and looking at transformations of rational functions to see what's happened. And think about things like moving, translating it left and right, translating it up and down. Think about stretching and just kind of reflecting over the x-axis and all the things we can do with any other function. First, let's consider f of x equals 1 over x. We know what this looks like. Nice, well-behaved function. So I'm going to use this function and I'm going to compare it with other functions. For example, suppose I'm given the function f of x equals 1 over x minus 2. So here's the parent function. What happened here? What is this minus 2 doing? Well, this is really the same thing as f of negative 2. Actually, let me call this g of x, okay? I'm going to call that g of x. And then I can say that g of x is really just, if I took f of x and moved it, it's the same thing as f of x minus 2. Plug x minus 2 in there, and I would get this. So what is this doing? It's moving it right 2 units. So g of x, this function, 1 over x minus 2, if I took this and moved to the right 2 units, then I would get that. Let's take a look at another function. Suppose I have h of x. So here's my first example. Here comes my second example. H of x, suppose it's 2 over x plus 3. Well, we already know what this 3 is doing, but what is the 2 doing? Well, I could rewrite this as 2 times 1 over x plus 3. So this is really, h of x is really just f of x that's been moved and multiplied by 2, a scale factor of 2, and then I've got f of x plus 3. So what's going on here in this one? Well, this has been shifted to the left 3. And what's that 2 doing out here? The 2 has been stretched vertically by 2. So stretch vertically by a scale factor of 2. Let's take a look at another function. Keeping the same one, I'm going to put the next paper over top here. So keeping the same one, suppose I've got some sort of k of x equals to 1 over 2 times 5 minus x. Now let's see, what's been going on here? Well, if I factor out the 1/2, 1 over 5 minus x, factor out a negative, and I'm going to put it out front, 1 over x minus 5. Now I take a look at this, and what's this compared to f of x? Well, it's so k of x is the same thing as negative 1/2 of f of x minus 5. So what transformations are taking place here? This is right 5 units, and then the 1/2 is I'm shrinking it vertically by a factor of 1/2. And the negative is a reflection. The negative is a, whoops, I'm off the screen, sorry about that, is a reflection over, with the negative there, what is that? A reflection over the x-axis. All right, so just reading the different transformations. Let's take a look at one and we'll kind of pull it apart and see what happens. Suppose I'm given the function, so we want to consider f of x equals 1 over x, my nice well-behaved parent function, and some other function, g of x, is 3x minus 7 over x minus 2. Now, what do I have to do to this function to get that function over there? Well, I'm going to use long division here. I'm actually going to divide this out. So I'm going to take 3x minus 7 divided by x minus 2. What times x gives me 3x? 3. 3 times x gives me 3x. 3 times negative 2 gives me negative 6. And then if I subtract negative 7 minus negative 6 is negative 1. That's my remainder. So if I divide this out, in other words, 3x minus 7 over x minus 2 is equal to 3 minus 1 over x minus 2. There's my remainder, this over the divisor. So now as I take a look at this, what transformations have taken place here? What's this 3 really doing? Well, that means it's been moved up 3. What's this 2 here doing? It means right 2. And then the negative is a reflection. Now, the reflection must be done before any vertical translations. So if I do these in order, I'm thinking here that it's going to be 2 units to the right, followed by a reflection over the x-axis, and then finally we're going to translate it 3 units up. So if I take 1 over x and I move it 2 units to the right, reflect it over the x-axis, and then move it 3 units up, I will have the same thing as that function right there. All right, so take a look at the homework parts from this. Take a look, and then we'll come back and we will talk about the harder case of dealing where the degree of the numerator is greater than the degree of the denominator. And we'll see some long division again.